Okay, so now we come to the complete algorithm, which is what is called as the longest prefix match forwarding. Almost the whole algorithm is what I have described earlier, except that now we have something called the longest prefix, which I am actually verifying here. Okay, so there is some additional checking that we are doing. What is this? Supposing you just think about it, you have this default entry, right? We said that any IP address will match that entry. Agreed?
Yes, ma'am.
So if you are sending a packet to a machine within your own LAN, also it matches it. It's not like it doesn't match that entry. It matches that entry also. But should you use the first entry in routing table of H1 or the second entry when you are sending a packet to a machine within its own LAN? It should be, the first entry.
Yes,
If you are sending a machine to, if you are sending a datagram to a machine in your own LAN, then you don't need to go to the router. You can directly simply do an ARP request, get the MAC address if you don't have the MAC address, and send the frame out. Okay. But, you can still match the default route. So which one should you match? How do you determine that? You determine that based on the number of bits in the mask. Number of bits in the mask for the first entry is 24 and for the default entry is 0. Okay, so always match the entry with the maximum number of bits in the subnet mask. That's what is the actual algorithm of the forwarding. That is what is called as the longest prefix match. Okay, so that's what we do here. Everything else remains the same. Longest prefix initially is set to 0. For every entry in the routing table, if there is a match between the destination network of the entry and the destination network you get by bitwise ANDing the mask and the IP address. You also check whether the number of mask bits in the entry is greater than the longest prefix you have found so far. If it is, then use this entry, right? So in this, the way I wrote this algorithm, you're going through every entry in your routing table, verifying whether the mask bits of the entry are more than the longest prefix already found. And if so, you use this entry, sort of a thing. But this will be too, it'll then lead to O of N algorithm, right?
Yes, ma'am.
And that's very, very bad for routers because they get so much traffic, they have to do very, very fast switching. Otherwise, there will be a lot of backup in the packets, and that's how you end up in congestion, and then you drop packets, and there's all sorts of havoc in the network. So what do routers do? They do a very fantastic O of 1 algorithm for that. Okay. They use what is called as, initially they used what is called as a binary trie structure, which has been expanded to become more and more sophisticated. Like I said, I'm not really going to discuss the data structures used, but at some point, if you're interested, you should read up maybe. And by the way, I want you to read the textbook for networking. If you are interested, I don't know. I would say you should read textbooks any which way for any subject. I'll send Douglas Comer's book, which is, I like it. It has very short chapters, unlike Euros and Ross or any of those books which have huge chapters. This is divided into small chapters, so it's very nice to read that way. Okay, so that's basically what is longest prefix match. Now, Once we understand this, then we can, answer questions, right? So I just wanted to specify that you can have what are called as host specific routes. A host specific route will be having a net mask of all ones. So the net mask for that routing table entry will be 255, 255, 255, 255. So it will always be the longest prefix. So if you have a host specific route, that's the first one that's matched. And if you have, and the default route is the last one that's matched. Okay, that's basically how it works. So a simple way of implementing this without using the trie structure would be to sort your routing table by the number of bits in your net mask. Okay, so the first entry that you find which matches is what you will use. That way you reduce the search search complexity. Now there are two commands you can use to look at the routing table in Linux, either route -n or netstat -rn. Okay. Any questions on this? So you can add, now I go even further, right? If you have no questions, this is the final example I take. Essentially, you have two routers, okay, and we are now moving to a very generic way of looking at it, not specific IP addresses. I say a router R1 is connected to networks N0 and N1. R2 is connected to N1 and N2. So you give IP addresses N0.R1, N1.R1, and similarly N1.R2 and N2.R2, which will fill the entries, first two entries in the routing table. Then I can add using the route command, okay, manually I can add networks into the routing table of routers or even hosts. So I do a route add command of this sort, which gives the third entry in router R1, right? So this entry basically comes from this command that I have added on R1. When I add this command on R2, I get this entry. Okay, so now this is our small world network, right? There are 3 networks only in our small world, and every router knows how to get to all 3 networks. So any host can talk to any host in this small world using the same logic that we have discussed earlier. So I can do ping n2.h2 from n0.h1. Okay. This is basically, so we started off with 2 machines on the same LAN. Then we talked about 2 machines separated by a single router. Now we are talking about 2 machines separated by 2 routers. And after this, it is generic. You can add any number of routers in between in the world, and the logic is the same. If you understand this, you have understood how forwarding works. Okay. So any questions? Here are questions for you to answer. And Bharadwaj wants to know how it works. Bharadwaj, now with the longest prefix match, you should look at the 4th question, and we can answer the question in the next session still if there are, you still have doubts.
Okay, sure.
What you need to do, you need to basically take every IP address I give there, okay? Try to match against every entry because I don't sort it for you, right? Find the longest prefix and that is the matching entry. Some of them may not have any matching entries, some of them may have multiple matching entries. You need to figure out which one of them will be used by the router. I have the same sort of questions here. Very, very simple questions, basically. Second question, for example, here. What is this route? Yeah? It has 32 bits in the mask.
Yes, ma'am. It is ho-
It's a,
like 32 bits means all of them are considered as network.
yeah, so what did I say? It is, it's basically, that's what is a host specific route.
Yeah, ma'am.
A host specific route has all the bits into one in the net mask. Okay, so when you see a route of this sort, you know that it's a host specific route. That's what you have to say. So the first question basically tries to understand how well you understood the concept of forwarding. The router has three interfaces. So far, I've shown you routers with two interfaces, but this router has three interfaces. And I've given the IP addresses of the router on the three interfaces. And I'm saying there is a host with this IP address wants to communicate with a host with this IP address. So you need to understand on which interfaces the hosts are connected to the router. Okay. You need to, I would like you to do what are the routing tables in all the machines. You don't forget the default route in the host. If you don't have the default route in the host cannot talk to any machine other than any machine in their own LAN. Okay. So write the routing tables for all the router as well as the host, and write what at every step, what is the IP address in the, what are the IP addresses in the IP header and the MAC addresses in the frame header, and it, it's a good exercise to see whether you understand the forwarding well or not.